user DB, we need a queue messaging system, and we need analytics DB for the analytics, and we need a background workers and web front end and API. So these are the key components in order to build a application, in order to run an application. So where we can run this application, we have multiple options you can see. Development VM, where a developer can work on the laptop and he can do code and he can test in local. So this is the one option. QA server, we have customer data center. So if I'm having a good money, I can buy my own server, set of servers like this, of 4 or 5 servers, and I can connect each other. I can host and I can connect the public IP address to it. So that is a customer data center. Or we can go with the public cloud like AWS, Azure, Google also. So to maintain high scalability and redundancy, we can enable DRDC concept. And finally, at production cluster. Production is nothing but we are using Netflix, we are using WhatsApp, we are connected on the Zoom, right? So this is a live one, production. So the application is going to run in the production service. And the last, end users can see here. Let me take my pen. So the end users can see here. So this is the end users can see in the laptop that what is my application is. So static website, user DB, web front end, queue, and this DB, and all will going to keep in one container. And this container we can expose in laptop also, we can expose in QA also, QA server also, we can expose in customer data center also, public cloud also, or final service also. So the only way to do containerization, this is the containerization, keeping all individual or different items in one place and running it as a one unit. So that this is my application actually. Okay, this is my application. In order to create this application, I need these items. These items has to be run at one unit. Then only my application can be completed. Then only my application can be say successfully. Queue is a messaging system. Okay, Anil. So that is going to be talk with your microservices. So we have a microservices. One service has to be wait for another service and it has to be subscribe and publish. So that is going to be happen to the queuing only. So that is queuing. I'll tell you that as well. In microservices concept, we are going to be discussed in just coming few minutes. Okay. So this is all the things I'm going to keep in one unit, and this one unit I can call it as container. So how can I make this container in application level or at server level? So what is the best way to do that? Okay, so that is Docker. So with the help of Docker, we can do containerization. The Docker is the tool which can help us to create this container. We have this container, right? Here, we are using an iron metal to create this container. Here, we use the Docker tool to create this container and keeping all these individual items in one place and making it to run at one unit. Okay, that can we can run in multiple platforms, multiple environments. One is a VM, which is nothing but a laptop. So at some point, I'll be going to be lagged by the space memory, right? Our laptop will be only 8 GB memory, right? Or 16 GB memory. So this is not enough. At server also, this server could be a 20 GB. This is also not enough. This is might be 100 GB. So like this, we can have a multiple environments to deploy this content. So if you can see all the static website and front end, background workers, user DB, and this analytics DB and queue, all are we are going to create each container also, and we can going to create all in one container. So to avoid the confusion, we can go with each one as one container. So with that, we can achieve the microservices concept. Okay. If you are going to keep all in one container, so that is going to be a single solution one. Okay. Single solution one is always at some point we are going to lag, because if my container is goes down, I cannot have my application up and running. So instead of that, going with the microservices architecture is the best method to deploy our application for high scalable. So let's discuss those things as well. If you can see, before containerization, we have a virtualization. The basic difference between the virtualization and containerization. So this is actually a bare metal where the server is we created. Let's take an example. A physical server. Physical server will going to connect with our port and cables, that is comes under a networking, which can enable IP address and port numbers. And this physical server will have an operating system. Operating system can be a Mac OS, or it can be a Windows, or it can be a Ubuntu, Debian, Fedora, anything. On this operating system, we can run our application by running any web server tool, or we can also directly connect our code to the server. So this is the a general way we do application deployment in one server, a physical server, or it could be a cloud server also, one plain server you can say. So, but I would like to run many apps. Like if you can see, in this case, we can run only one application. We can run only one application that we are going to connect directly a code to the server. I would like to run one or more applications in single server, single physical server. So how can I? I need to go to the virtualization map. So in virtualization manner, so we have to install the operating system on the same server, and then we have to install hypervisor, which is virtualization, and we can also call it as VMware also. VMware and hypervisor both are the same. Okay. Previously, we used to call it as hypervisor because we have a Windows systems, and right now everything is Linux and Windows also, right? So we are going with the virtualization term, which is VMware. Once you install VMware here, so it is going to enable to you to install other operating system also. It is going to create a separate network for you in the server. It is going to create a separate network for you in the server. When it is going to create a separate network, so you can have multiple interfaces. On one interface, you can have one guest operating system. So this can be a Mac OS, and this can be a Windows OS, or CentOS, or Fedora, or Debian. So you can also install multiple operating systems in single server, and each operating system you can test your application. On each your application, test your application. So this is virtualization. To understand very clearly, I'll take my paint and I'll tell you. So with that, we can have a clarity. Let me take my paint. So previously, before Docker or before containerization, how the deployments are going. So this is the main thing we have to know. Let's say I have one application. So this is my app. And this app, and let's say this is Myntra or Flipkart or Netflix. Netflix is developed by a developer, and he has tested in local development VM, which is nothing but a laptop or a desktop. And then he has to test in one server, right? So this server, I'm going to keep it as one dev server. And then one more QA server or UAT server. I can say user acceptance server. And then the final one is a production server. Okay. So my developer will deploy this application in dev server through the Linux admin. And once it is deployed here, so what are all things are inside this server? So we have an operating system here. On top of this operating system, we are going to run our application. This is our application. Let me take it as in red. In the same way, here also I'm going to have an operating system, and here my application will run. And here also my operating system will run, and then here my application will run. So we are going to do deployments in 3 servers. Okay. Now the testing is going on 2 different servers. One is dev server, one is UAT server. So in dev server and UAT server, let's say developer has to check, it has to work on Chrome browser. So it has to work on Edge browser. So it has to work on okay, it has to work on Internet Explorer, or it has to work on, let me take my pen. Yeah. So it has to work on a Chrome browser, starts to work on Edge browser. So we will check this Netflix application should work on each individual browser. So we are going to create one server for Chrome, one server for Edge, another server for Internet Explorer, another server for Brave, another server for other web servers, okay, or web browsers. So in order to support this Netflix application, we have to create each individual server for each individual testing. So this is a biggest disadvantage in previously we are having. So we need to create this server and we need to deploy here. We need to get an operating system. We need to deploy application and we need to test. Once it is passed, we have to move to the UAT and where manual testers will do the testing and all. Once it is passed with their checks and all, it is going to the production. So this is how previously we are doing a testings on the server. We have to create all the servers, right? Here we are wasting money and we are wasting the infrastructure. So I don't want this kind of infrastructure. I want to go some more automated. So that time virtualization. So what a virtualization will do, now I have my application here, same way. And then I have one big server. So this is my app and I have to deploy here. So what I'll do, I'm going to have same network, operating system. This is the operating system. Let's say this is Linux and I will be having VMware installed on top of it. Okay. Or hypervisor VMware. When I install VMware here, it is going to enable isolations for okay networks. It is going to create a different networks for me in this server. So here it is going to give me a network to run one other operating system. So this operating system can be a Mac, okay, Mac OS. And this one is going to be another one like Windows. And this is going to be another one like CentOS or Fedora or Ubuntu or Debian. Okay. On each operating system, I can deploy my application. These circles are nothing but my applications. Now, see, on the single server, by giving a more space, let's say I took 100 GB. Okay. On single server, I can able to create 3 more virtual servers. So I can call it as Mac as a dev, Win as a UAT, and Debian as a production. I can also uh, take it like that. I can also take it in a different operating system to test my application. By creating one single server, by giving a more memory, and by enabling the VMware in it, we can do testings like this. So this is the virtualization use. But okay, this is a more good way to use virtualization. Then why we need to go for a containerization again? And why the Docker is came into the picture and it is having a high trending things. So let's discuss that also. Let's understand first limitations here in the virtualization. So in this virtualization, my application is running here. Let's say, uh, let me take this one, my pen. So I have app here. So this app, I would like to move to another server. I have another server now. This app, which is running here, I would like to move to this server. I can't. It's a very challenging. Again, I have to connect all the networks, servers. I need to enable or FTP, or I need to enable SAP tools, SCP tools like secure copy things. So, or I need to go with any third party tools in order to connect. So that is has to be done at physical data center. So this is going to be a challenge to a Linux administrator. Okay. So this is the first challenge we have, and the memory. We need to provide memory. It is not a lightweighted one. In the single server, we are installing operating system. This is the base operating system. And top of it, we are installing the VMware. Let's say this operating system is took 5 GB, our base operating system. And VMware took a 20 GB. And each operating system is taking again 20 GB. Okay. Again 20 GB in the server. And I have deployed my application here in the Debian, and it is taking out of this 20 GB, it is taking 5 GB in initial phase. When my tester again had a new changes and from the developer, and he has again deployed, and now it is creating more file system and it is running more high process. Now it is occupying around 10 GB. And in the next 15 days, again, my developer had a new changes, and again, my tester is deployed here and is go for again testing the application, and the application is running and it is creating a more file system and it is going to use more running process. It is reaching up to 18 GB. So we have allocated only 20 GB here, right? Okay. And it is coming to 18 GB. So this is the limitation we have. So in order to again increase the space, we need to connect extra space to this network. And that is a challenge again to run multiple commands in the Linux servers and to connect them. So most probably we'll get a lot of errors actually. So this is the limitation, the biggest limitations by going with the virtualization. Okay. Now the Docker came into the picture, and Docker is telling us, hey, why you are doing virtualization? I came up with the solution like containerization. Containerization is a very lightweighted one. You can run on very simply on any of the environment. Let's understand that as well. If you can see these images, virtualized, containerized. Okay. Right side, containerized. So same physical server, host operating system. but we are going to install Docker instead of the hypervisor. But here we need to go with the again one more operating system, but in containerization we cannot. So we don't want to use the operating system because Docker itself is enabling a feature you can run on the same base operating system. So you no need to go for any guest operating systems. So that is the containerized feature. Okay. So you can see the difference here in the images, same infrastructure and operating system, container engine, but in the VM virtualization, we need to go with the guest operating systems. Okay. And you can see the Docker architecture. So whenever we install Docker in one server, so this is the architecture it is going to behave. The first one is CLI or API, which is the client one, which communicates with the daemon. So daemon is responsible to manage your containers, to manage your network, to manage your images. And a registry. So this is the registry where all Docker components and Docker things are available. So that is nothing but the Docker registry or Docker hub. So we can pull Docker images freely from Docker registry. Okay. So let's understand. So what is a Docker images? If we can see, these diagrams are referring to the Docker images and the Docker container. And to avoid the confusion in these images, let's go to again paint and let me give you more insights on it. Now, I have application here, my application, and I have one single server. This is my app, and I would like to deploy here. Okay. For this app, I can run in one single container. So this is my operating system. And top of it, I'm going to install a Docker. And top of the Docker, I can run multiple containers. This is base operating system, and this is Docker, and this is container. Okay, these are the containers. So when I can deploy my application into a container, okay, I can run each container as one application. Again, container means it is a running virtual server for our application. So inside this container, we are running our app. Inside this container, we are running our app. And it is very lightweighted one. Hardly it is going to create 100 MB or 120 MB or 500 MB. That's it. The container will have hardly 100 MB or 120, 500 MB only. It's not more than that. It's a very lightweighted one. And I can easily move this container to another server also. And it is easy to run, very dead easy to run as well. And I don't need to be worry about the operating systems because I can run on the base operating system. So whenever I install the Docker here, so this server is going to call it as Docker host. Okay, Docker host. So this Docker host enable one network for me, and this is going to communicate with my base operating system. And here I can deploy Netflix application in this container. Here I can deploy Amazon Prime application. Here I can deploy any shopping or e-commerce application in single server. So in single server, I can run multiple applications. So when I say different names for Netflix, Amazon Prime, and e-commerce application, so these are the a single solution or a monolithic applications we can say. So monolithic means if I want to update something, so I have to down this container and my application will be going to down, and my end user who are the customers using actively in the mobile, they will get an interruption. They can't access the application. So that is called downtime. So that is the case in the monolith. But in the microservices, when I want to update anything, I can update my specific microservice without disturbing another one. Let's discuss those things as well. So this is the a Docker architecture. Once I install the Docker inside the server, then I can enable multiple containers and expose multiple containers on the Docker host. Okay, with a different port numbers. Let me show you some images regarding this. Okay, so this is the Docker image, and this image we are going to convert from our code base. Let's tell you that as well. How we are going to convert? Let's say my developer has written codes here, and this custom code, this is a very custom code, right? My developer written for my project, for my business. I need to run it as Docker image. So for that, we are going to write one Docker file. And this Docker file is going to convert as one image. This is a Docker image. And this image, we are going to run it as content. This container is nothing but my virtual server. Image is nothing but again, it is converted into binary format only. It will have binaries and libs. Libs means libraries. Okay, binary language we have studied in our BTech, right? Same way, it is going to convert into a binaries and libraries. So combination of binary and libraries is the Docker image, and this image we are going to run it as container. Okay, from my custom code, I will be going to write one Docker file. This Docker file is going to convert as a Docker image, and this Docker image can run it as a container, and then I can see www.netflix.com or amazonprime.com or mintra.com. So this container will run my application. Okay, and we have other predefined images as well for the Docker to use. So where we can get this one? So where we can get these images? So we can get these images from the Docker registry. Yes, we are going to discuss about the Docker file as well. So we can get the images from the Docker registry. You can search registryhub.docker.com. You can able to find all the images. So let me log into my Docker hub. If you search Docker hub, you can able to see this first link, and this is your Docker hub. Okay. If you come to the explore, and here you can search a multiple images. So these are all predefined images which is already available and ready to use. Okay, all these images. To understand in a very better way, let's create a server or let's do some practice. So where can I do the practice? You can do practice on AWS EC2 as well, or you can do on Play with Docker. So we have a separate site to do practice for this Docker. You can go with labs.playwithdocker.com. It is going to give you a free server from the Google Cloud. Okay. So let's go for it. Play with KTS. Sorry, play with Docker. First one, click on first one. So this is play with Docker. So this is going to ask first login. The login should be your GitHub or your Docker Hub account. You have to create a Docker Hub account. Once you have logged in, it is give you start option. Once you have started, it will give you a free platform from the Google Cloud. Okay. And this is going to give you up to 4 hours. And now I want to create a new server. Left side, add new instance. Now my editor and you can see my server is ready now and it is giving me CLI as well. So let me make small. Yeah. Yeah. Okay. So this is now my Docker host. Already Docker is installed here. Docker version. Okay. You can see the Docker version 24.0.7. This is the Docker version right now in this server is installed. And all the dependencies also is installed along with this Docker here in this server. No need to worry. You can just go for the practice direct. Okay. As we discussing just before, what is a Docker image? What is a Docker container, right? So let's understand in some practical way. Now I would like to run one image. I would like to pull one image. If I come to my Docker Hub, here you can see I have multiple images. Okay. So let's take one web exposed image. Nginx can be exposed on the web. I'm clicking on the Nginx. Nginx is the web server tool which help us for the uh, exposing the application on web based. If you can see in the right side, it is giving me a command directly docker pull Nginx. So always we need to provide the Docker first command, then only Docker engine can understand this candidate it wants to talk with me in the server. Okay, so here, so this one client. So whenever we want to talk with the daemon, we have to provide Docker the first command, Docker. Without that word, it is not going to understand. So if you're not providing that word, so that is going to discuss with the base operating system. When you provide Docker only, it is going to talk with the Docker daemon. Docker pull Nginx. If you can copy this, or you can also run in the directly in the CLI. I'm copying it right side and click here and shift insert here. Copy paste will not work. You have to do shift insert and hit enter. Now what it is doing, it is pulling a Docker image from my registry. Now image is pulled into this server. How can I check the image is here or not? You can check with the Docker images command. See, Nginx and latest. So this is the image ID and it was created. This image is created 3 months ago and it is having 187 MB. Just 187 MB. So this is my container, right? So sorry, this is my image, right? This image in a format of binaries, in format of libraries. Okay, including the both libraries and binaries. So this image is created. Now I would like to run this image as a container. Docker run -p 2024 is my port number, and I'm going to give 80 because web server is going to talk on 80 port number -d and nginx my image name. Okay. When I have given, it has created one hash ID. So this hash ID is my container. Okay. How can I check this container? Docker ps. See, this is my container right now. It is running. And in the above, automatically one port number is enabled 2024. If you click on this, it is going to open a new window and it will going to show you your content. So you have written Nginx, right? You have downloaded Nginx image and you have exposed it. So it has to show welcome to Nginx. Let's wait for a few seconds to load because it is a private server. Yes. See, welcome to Nginx. Now it is giving me welcome to Nginx. I have downloaded the Nginx image and I have exposed as a container. In single server, right now, I'm running one container, which is Nginx container with one port number 2024. Can I run one more container in the same server or not? Yes, we can run. Now, I would like to run my custom code. I would like to run like a welcome to Docker workshop by Rajnikant or welcome to students for this workshop. I would like to write something like that. I don't want to go with the predefined things. I would like to go with the my custom uh, application. Let's say that is a custom thing. So let's go to the playground and I will be going to create one Docker file. Okay. So before that, I will create an index.html file which can access on the web. Vi index.html, and here I'm going to write space. Welcome to Docker workshop. Okay. I've given my name. Escape shift colon WQ exclamation mark. Okay. Now, if I give ls command, I can able to see my file index.html, and I would like to expose with different port number by running a different container. To do that, we need to write a Docker file. So vi Docker file, and here I would like to Yeah. Am I audible now? Can anyone confirm me? Yes. Thank you. Thank you. Sorry for the interruption. A sudden network outage. Okay. Let me share my screen. I hope my screen is visible. Yes. Thank you. Thank you. Thank you very much. Now, what I where I'm okay. So I'm writing a Docker file right here. So I would like to expose. So this one, let me go back and create a new file. And yes, so I would like to run my custom code. So let me go to the HTTPD images because we already use Nginx. HTTPD is one more image which is going to enable us for the web-based. If you can check this one, click on this, it is going to give you an options. Okay. So if you come down, so it is giving you the suggestions how you can create your project as well. From HTTPD 2.4 and copy public HTML users local Apache htdocs. So this is the instructions. We will discuss the Docker instruction, what it is. First, let me write this one. Okay, from HTTPD colon 2.4 and then I have to write copy. So it is going to do copy from this directory, my index.html file, to my Docker image. Okay, so slash usr slash usr slash local apache to htdocs, local slash apache to htdocs. Now it is going to copy my index.html into this path into my Docker image. I can escape shift colon WQ explanatory mark. It is going to save. And if I can see, I have index.html and I have Docker file. Now I would like to run an image from my Docker file, which is having my index.html. Docker build -t. So this is, I'm going to call it as web image and dot. Dot in the sense, in the present directory, it is going to look for my Docker file. Now it is creating an image. You can see automatically it is created an image. Now if I can see Docker images, I can able to check 3 images. Okay. Give me a minute. Yeah. So I can able to see 2 images here. One is Nginx, one is web. Okay. So now I would like to run as one more content. Okay. Docker run -p 2025 Now I would like to run. And 80, again, it is going to listen on my web browser, web port 80 or 8080. And -D, my image name. That's it. It is going to run one more container. Now I can see Docker PS, two containers are running right. Okay, two containers are running right now. So let's go and see 2025 port number. Before that, 2025 port number. Okay, let's wait for a few seconds because it is a private server. You can see, welcome to Docker workshop by Rajnikant. So it came. So this is my custom code, right? So in the same way, let's do some more practicals to understand more better. So for this, I will going to create an AWS EC2 instance for it. So let me log into my AWS account. Once you have logged in, go and create one server, EC2 instances. So let me switch to my favorite region is Mumbai region, and create a server. So here I'm going to call it as Docker VM or Docker host. Okay, let's give the good name Docker VM, and I'll be selecting Ubuntu. So please go for and do practice always on Red Hat or Ubuntu. Linux, again, it is a plain things. Everything you have to configure and add the packages and add the repositories. Linux will be used for only POC purpose or testing purpose. But in real-time industries, everyone will use Ubuntu or Red Hat. Okay. And we will use CentOS and Fedora for the testing purpose. But so this is my key pair. And then I would like to go with the existing security group. And so let's take a 20 GB because we are going to deploy applications. So I need more space. And launch instance. Now it is creating a server in my AWS account. Let me connect to this. Go to connect, SSH client, copy it, and open your CMD. And one more thing I would like to give you suggestion and a good practice. Always use the CMD. Don't go for any mobile extreme or putty and all. Now companies are not using any mobile extremes and putties and all. Okay, everyone is using CMD, the itself default CLI terminal. So we have to configure all CLIs, AWS CLI or Azure CLI, whichever the project you are working on. You have to enable CLI things from your CMD only. Okay. So now I have my key pair in this location, downloads location. I'm connecting to my server. I have connected sudo su. So I'm logging as an admin user and I would like to install a Docker. It's just a single command to install the Docker. Snap install Docker. That's it. It is going to install and it will run. No need to give 3-4 commands. adding a repository, adding a installing a Docker and running it as a service. No need. This single command can do all the things in the server. You can go with Fedora or you can go with CentOS also. If you're going with Fedora and Red Hat and all, you can go with DNF or Snap. So these are the CLI components which help you to install very faster. Yes, now I have installed my Docker. Now I would like to run my application. Let's say I would like to run one single layer, which is static application. So how can I? So let me go to one code. So static websites download. So go to this first website. Here you can see you have a lot of templates here. Let's select any good template. So let's check this header. And I would like to download this one. Copy link address, come to your server and give wget and it. That's it. Now you are downloading your code, which is written in CSS and HTML. Okay. And that is in the zipped format. We need to do unzip. So for that, we need to install unzip component package. Now unzip it. If I give ls, you can see preschool website template. So this is my code. If I log into it, I have code. You can see index.html and images, lib, JS, CSS, HTML. All the codes are here right now. So this code I would like to run it as my application. So how can I do it? So to do that, we need to again write a Docker file. Writing a Docker file is just a static application we are exposing. So we can go with the same HTTPD. So I will go here and copy this and come here and paste. But I don't want this. Because of this, it is going to block my communication to the index.html. So we need to remove this, escape, shift colon WQ exclamation mark. Escape, shift colon WQ exclamation mark. Okay. If I see my Docker file, so this is the content here. And now I would like to run it as image Docker build -t. Now I'm going to call it as website. Okay. Dot. It is going to create an image for us. You can see automatically it is an image. So it has copied my all the code into this path. You can see and you can follow this log as well. It will give you a clear clarity how it is running with all exporting layers. And you can see ls and Docker images. So I have my image here, and now I would like to run as container-p 2023 and 80 and my image ID. So here I'm going to give run in the background, and now my content is running. You can see. And Docker PS, see, I have my container ready. To check this, go to your instance, take your public IP, take the public IP, and come here and give 2023. So that's it. Your application is open right now. So this is just a static application. So whenever you're opening Netflix, whenever you're opening Myntra, whenever you're opening Flipkart, the first page you are seeing, right? So that is a static application. Okay. You can also access this IP address I'm giving you in this chat. Okay. So you can access also. So wherever you are, you can able to access this website. So this is the static application I have deployed. In the single server, I can run multiple contents, a multiple application. In the same way, I can run another application also. In the same way, I can run one or more, two or more, three or more applications I can run in single server by doing a containerization. So this is actually how it works. So how we are implementing in real-time industry. Okay, so let's discuss that as well. So I hope you got this point, how we are creating an image from the Docker file and how we are running the container. And if you clear this, so I can go in more deeper to make you understand on microservices part. Can anyone confirm through the chats? Clear. Okay. Okay. Cool. 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 Okay. So Patrick Joshi, you not got. Okay. So let's make very clear. Cool. Cool. So I got good response. So I can increase some dose if you're understanding this basics then. I have provided IP already. Let me give you IP. IPN 2023 port number. I have given in the chat. You can just check. If you directly go and click on it, it will open you in the browser. Okay. So this is static application. Let's compare a Flipkart. Okay. See, this is static application. This is when I click on login or when I click on become a seller, when I click on something, the pages are loading, right? The backside pages are loading. So this is dynamic. Application called as dynamic. It has some front-end code and back-end code and database. So then only it can be called as dynamic application. So did not get the IP. In the chat box, you have see Shahid. In chat box, I have provided the URL along with the IP and the port number. Rohan Singh, sir, this application is based on HTML and CSS, or application is based on the JavaScript and database. Then how we can do? Yes. Now we are going with the React JS JavaScript zone. Okay. Okay. I think let me give you here. Now, can you just please check on the chat box? The next step is we are going with the JavaScript zone. Okay. When we connect with the front-end code and back-end code and the database, that application can call it as dynamic application. So all the applications we are seeing on the web right now, Flipkart, Myntra, Netflix, Amazon Prime, everything is a dynamic application. Okay, everything is having a backend code and database. So right now we have successfully deployed one static application. Let's see to do dynamic applications as well. Okay, so in industry, how this Docker is using, for example. Okay, let's discuss some architecture of the microservices and monolith. Okay, then you will get a good picture on it, and then we can go for a practical. So for that, let me take a board on the online. Abid Ansari, Ubuntu, Docker file, Docker image. Container, right? Yes, it is a container, but we have to discuss two different things here. Okay. Ubuntu, again, we can use it as image and container, and again, we can directly use the code image as container. Okay. Let me give you clarity. Let's say this is my application. Okay. So in this application, I have login here. I have products here. Products like biryani, pizza, and all. And I have other cart option here. And I have payment option. Okay. So this is going to be shown in the front. The options. This options is going to show in the front end, right? Whenever you logged into the application, you click on the cart, you click on the biryani, and you have checked out for the payment. Okay, or you created an account. So this is going to happen through the backend. Okay, so here in the backside, we need to provide one backend, right? Yes. And then we need to have a database where all these things are going to store. So my login credentials, my username, password, this payment amount, and who has added wish list or add to cart things. So these are all things has to be stored in the database. Database is going to store this kind of information. Okay. So I have backend code and database, right? So to run this application successfully, how many containers I need? I need one container, front-end container. I need a back-end container. I need a database container. We can also put all these three in one, front-end and back-end, front-end and back-end in one container, in one container. So when my container is running on 2023 port number, okay, when my container is running on the 2023 port number, I have front end and I have back end code. And my developer wants to do some change. Actually, it is needed. So new feature has to be enabled in the front end. And for that, we need to write first backend code. So always in the industry, the developers will do backend code first. Then after they will do front end code. Okay. First deployment will be always a backend code, then the front end code. Okay. So when my developer did some code changes in backend or in the front end, so when I'm going to apply these changes, I need to down this content. So this is how I can experience some downtime at my end users. So this is monolithic. Okay. Monolithic. Monolithic means, so without stopping this front end, I cannot update the backend. So I need to down all the content. Okay. So this is single solution or a monolithic. So in microservices, yes, each individual, for front end you are running one container, for back end you are running one container, and for database you are running one container. So you can update your changes here without disturbing this container. You can update your changes here without disturbing this container. And you can update your database container without interrupting these other containers. In the same way, in the front end, we have cart, we have login, we have products, we have account, we have payment, right? Each option will be the one container. Okay. If you can see here, sell online, it will be a one container. Okay. Shopify will be a one container. Okay. Login will be going through a database. So it will be a normal one. If I come back, so I have cart is one container. So I have all these options type. These all options are products and categories. Okay. Login is one container and search is one container. Okay. So whenever I want to do update something on the search, my developer can do updates on the search without disturbing a login. So this is the microservice. These are all running through the microservices. Okay. To deploy multiple containers in single server, how we can do? So let's deploy one container with one solution and let's deploy 2, 3 containers to make one application. Okay. So let me go to my instance again. Now I would like to go with kind of a monolithic, okay, a kind of a one single container where my application can run. So now what I'll do, I'll come back from here and I would like to clone one code from my GitHub. So I'll be having my repositories here. Copy this code and come to my CLI and provide this. Now I'm trying to deploy a Netflix one. You can see. So the code is downloaded and let me log into it. ls. I have a Docker file, you can see. Okay. If I cat Docker file, so I have some instruction. Okay. I have some instruction. So these instructions from it is going to run my node image. I'm directly using node. I'm not using any Ubuntu. If I use again Ubuntu, again I have to provide node installation inside my Ubuntu. So that is going to create a more MB for your image. So by writing this kind of instruction, you can decrease the size of the image. And then work directory where my application uh, code is going to copy inside the my Docker image, and all the files which are here, it is going to copy inside this app directory, and then it is going to look for one of my argument which is API key. Okay, so this is the key which is going to connect with my database, and then it is going to build inside this container or inside this Docker image. And then again, I'm providing one more from and one more work directory, one more run, copy, expose. So this Docker file is a multi-stage Docker file actually. So with this writing a multi-stage Docker file, we can expect the image size is very less. Okay. Hardly it could be a 150 MB or 500 MB. That's it. Okay. When you're writing a single Docker file with all instruction, it will go and create more MB. So it is an interview question. So how can I decrease the Docker image size? By writing the multi-stage Docker file. So now what we are trying to do, we are building the code by using node 16 image and we are exposing the same with Nginx image. Okay. And the most asked interview questions, the difference between copy and add, the difference between CMD and entry point. Let's discuss in coming few minutes that one as well. First, let me create this image through this Docker file. Docker build -t. I'm going to call it as Netflix and dot. Now it is creating my image. So it is connecting with the database. It is having front-end code. It is having back-end code. But I am running only single container. Okay. I'm running only single container. Let's see. So means single code including front end and back end. Okay, including front end and back end, and I'm running a container, single container. This is my container. So I'm running a single container, including front end and back end and DB everything. I'm running a single container, right? So now my image is ready, Docker images, and now I would like to run it as a container. Docker run -p. Okay, so let me first list the Docker file. So which port number we have given? Docker file we have given 80. So now Docker run -p 2025 colon 80 and -d Netflix. So this is my image name. If you give like this, so it has created container Docker ps. See, it has created my Netflix container. Now I'm running a single container with front end and back. Now let me come to my IP address where it is this one, and let me copy the same and let me open the one and I'm giving the 2025. See, it is directly opening a Netflix application which we can able to play the movies as well, and you can directly access as well. I'm giving you in the chat. Okay, so we can play the movie. Now it is connecting with my backend. It is connecting to my database as well. Okay, so all these are running in single container right now. Okay. If I want to do some update, and this update, let's say in my list, I would like to add my wish list. So that is going to my second change. So that change has to be automatically need to be happen here. So without interrupting this container, I cannot do that. Okay. So this is the single container with multiple things, keeping it in one container and running it as a one unit. I don't want like this. I would like to run different. So I want to run front end separate, back end separate, database separate. To run multiple containers to deploy one successful application. So we can go with Docker Compose. So we have a one more concept called Docker Compose. No, it will come Amit Singh. Can you just check again? Remove the browse option. Let me give you like this. So this is going to work. Click on this URL and you can able to see the application. Now instead of this, I would like to run a different containers. Okay. So Docker Compose, what Docker Compose will do? So I have one front end container and I have one backend container and I have DB. I'm going to keep all this in one file, which is Docker Compose. Okay, which is Docker Compose. So what happens here when I am running this compose? So it is going to create this container. It will go and create this container and it will go and create this container. 3 containers it will going to create, and it is very easy to create with a single command. So previously I have ran one command to build an image, one more command to build container. So I have run 2 times 2 commands. But by using Docker Compose, I no need to run 2 commands. So if it is the previous practice, For 3 containers, I have to run 6 commands. But instead of running that, you can use Docker Compose and you can run one single command. It is going to create 3 containers at a time. And with the another command, at a time, it is going to terminate all the containers. Okay. Let's see how it is going to happen. Now let me go to yes, it is available in the YouTube after some time as well, Sumit. You can check after I think 10 hours or 24 hours. If you can see this Docker Compose, so I would like to write a Docker Compose for it. Okay, let me go to my repositories, and I have one repository here which is user registration, okay, or a student registration. I have front end code and back end code. So this is a client and this is a server. Okay. Now I want to run this, clone this one to your server. ls git clone, and let me log into my folder. And now I have Docker Compose YAML. Okay. So I need to just run one command, okay, which is docker build docker compose up build. So this is the single command we can run here, docker compose up build. That's it. It will go and create containers for front end, for back end, and database. I am using a database here, MongoDB, and we can able to see after this containers. So let's give 1 minute of time to create it. Now it's about to complete. Successfully created 2 containers. Yep. Now it is running. Now my database also running. And meanwhile, let's check the code. If you can come and see docker compose.ym. It is a YAML syntax which is having a client, the first one, it is going to run on 3000 port number, and the backend is going to run on the 5000 port number. And MongoDB is going to run on 27017. Okay, so because of this single file, it is creating my front end Docker file. You can see here, I have a Docker file. And in the back end, I have one more Docker file. It is going to look for this file and it will create. Okay, so let's see. Still running. Let it run. Okay. Now let me take the IP address, the same IP address, and I would like to run with 3000 port number. See, it is open a registration form for. You can provide your email address like email or rajni.vatla@gmail.com. If you can see, it is going to only validate only Gmail things. If you give any other extension, it is not going to take. Please use Gmail account. See, so it is not a Gmail because I have given a wrong spelling. Now Gmail. Okay. Now register. gmail.com. 1 2 3 4 5 6 7 8. Register. See, form submitted and check for the console date. This is just a sample one which is having a registration form, front end and back end. If I come and so these are the three containers it has created. One is MongoDB and another one is backend one and front end. Okay. So let me replicate this one and let's see the containers. Connect. Sudo so docker ps. See, you can see I have these many containers right now, which is running on 5000 port number, my backend and front end and database. So Vikas Sharma, it is not good to run the database in the single server. So right now for this demo, I'm showing this in a single server, but this is the advantage. But you are running database as a container. Okay. So here you no need to worry about it. You will be not having any risk actually. So to make high scalable for your database, so you can go for the Kubernetes for creating auto scaling process. But here by using a Docker, yeah, however you are running a separate container for it. So why would you need to worry about it? So when the database also in the same kind of integrating with the same server without the Docker, then you have to worry about it. Okay. So container will not crash. Container will crash only when you have a wrong code commits in your code base or wrong environment variables you have provided in the Docker image. Then only it will go and exit back of the container until and unless it is not going to. Okay. Now you can see three different containers are running for my registration form, right? The front end, back end. So let's deploy in the same way one e-commerce application as well. Okay. So let me down this one. See if you can see right side, I have three containers, right? So let me keep it in a watch. Watch in my CLI not working. Let me okay. And come down and I would like to give a control C. Okay. Now all the containers are exiting. Now it is going to stop. Stopping. Yes means it is stopping. Cancelled. If I come, give Docker PS, see my containers gone. Only I have two containers. See. Now let me go with one e-commerce application as well. Git clone my URL ls and cd e-commerce ls. You can able to see one Docker compose file here. Okay. So let me run the same command. Okay. So readme Docker compose up build. So you have to run the command where the compose file is available in the same directory. You have to run. Yes. So this is the thing. That's what I'm telling. See, I have front end. We need to write a one Docker file. Back end, we need to write one more Docker file. Okay. So these are two different containers. In the same way, inside the front end also, if I have API gate, for API also I need to write one more repository, one more Docker file. For account also, I need to write one more repository, one more Docker file. For payment also, I need to write one more repository, one more Docker file. So each Docker file will be each image and each container. So like this, we are going to run a multiple containers in the company. So whenever you're deploying all the things in the Kubernetes, you are going to deploy almost all 50 to 60 containers. Okay. So everyone is showing just a single containers for single solution applications. So this is not used in the companies. Okay. Inside the companies, we use the microservices more. We are not using more on a monolithic. So otherwise, we go with the single solutions like Angular based applications. Okay. Just for a normal static registration applications. So let it run. Now, if you can see, it is created. Now let me come and remove this and let me search this one. Now see on the same port number, I can able to see my e-commerce application. So which is having all the vegetables in it. So to make it more real, let me configure DNS as well. So how in a real time we are using a Zepto, how we are using a big basket. So you can consider this application same like a big basket. Okay. For that, uh, give me a minute. For that, let me go to one DNS, free DNS site. So you can able to find the free DNS, static DNS subdomain, free afraid DNS. Open it and go and register with the sign up free. So how can you go? Go and create temp mail. Temporary mail. You can check this one. It's a Cloudflare. See, which is nothing but a content delivery network and secure enable. Now I'm going to copy this one. Copy this email and come here. I'll be giving in the email section and I'll be providing DevOps, DevOps 1, 2. And here I'm going to give as Rajni is the last name and user ID is the Rajni Docker, I will say. And I'm going to use Docker as the password. And I'm going to use the same password. And here give the captcha. F-O and agree this, send an activation. Email has been sent to my account. Come here and check in the inbox. I should see one email here. Let me refresh. See, I got one email here, you can see, and click on this. So it is going to give you one URL. So you have to open that URL. So copy this URL up to here and open a new tab and paste it. So it is going to add a domain. Now I would like to add a domain with my server IP address. What is my server IP address? So it is somewhat 13,233 something. So I need to provide this IP address here, destination. So we need to configure a record for it. So let me give Rajni docker.mo.com. Okay. So Rajni, talker.moo.com, and I would like to enable for all the subscribers, and NNFE is my captcha to it. Wildcard unlimited were taken 1 minute. Let's come back. So let's go with Rajni only. Different image. GNMI. Now my DNS is created. If you search this one here, so we are not able to load anything. Okay, the first thing, we are not able to load anything. So in order to configure this, DNS has to open my website. We need to perform a few command things. So let me install Nginx in the server. So here we need to run Nginx apt install Nginx. Okay, so we have installed the Nginx right now. To configure in that, let me take some commands. Okay, so I have my browsers. Let me open a file for it. Service Nginx start already started. Let me come back for it to enable. vi /etc slash Nginx, or let me take directly this path. So instead of avoiding the failures, so let me go to this vi, and this is my DNS, right? So copy this one, come here and not provide here and enter. And here you have to provide, so this code. So here we need to give our domain name. Okay, so domain name is this one, and come here. So this one, and let's provide one more time the same way. I think it's enough. Now come here. Here we need to give the IP address of our server. So server IP address is this one. That's it. Escape, shift colon, WQ, exclamation mark. Okay. Now it is going to run. So let me restart the Nginx. So sudo Nginx -t. Let's test that. Now it is running. And let me reload sudo service Nginx. Reload. Sudo command syntax wrong. Yep. And come to my DNS and refresh. So still it's not taking. Let me check one more time. This configuration mo.com. This is the available site only, right? So let me enable one command. So this we need to provide actually. So then it has enabled. So let me do with here our site, which is nothing but this one. Copy, paste, enter. And now let me reload the Nginx. Okay, it is config failed, no such a file or directory. No, we shouldn't use this one. It's giving an error. I have written two times, right? Instead of this, I have ran this. So let's do some change. So let me run this one and this one as well. And now let me do a reload. Sudo service nginx reload. Again, it's getting failed. If I come, refresh, still it is not loading on it. Nginx. First, let me start it. Now, let me come and reload. No, it's look like DNS already. No, DNS is not taken. It's my own DNS right now. I'm just trying to forward to my IP address. So here we need to do certain configurations in order to understand the web connection. So in place of DNS, IP address will work, already working, right? Here you can see you can create an account, everything. So my point, I am just see in place of IP address, I'm just trying to keep the real time like rajni.mo.com. Like you are searching, right? www.flipkart.com, www.something.com, right? So if you can see, so this one, I'm not able to see the NS lookup. NS lookup and my DNS, so it is not directing actually. So I have successfully mapped my EC2 IP address. You can see NS lookup and this one EC2 IP address. The only way that what I'm trying to do, so this IP address will only work on 3000 port number. If I normally give this single IP address, it doesn't load anything because it has to look for the Nginx. So that is the problem here. So that's what I'm trying to do. Just give me a minute. Let's complete this. No, it's not coming. That means problem with the Nginx. So okay, so let me check it out one more time with the same configurations. Let me do the same things, repeat again. So Srinivas, where it is showing next, where no, the host name is already taken. Acha, let me give one and let me take X, X, Y, and D. Save it. This is my DNS now. One.com. So let me do again the same process, but it is already mapped here. So it has to work. Let's do one more time with the one, and let's do with the enabling VI, no QA. So here we need to provide one. So which is one, right? One. I need to give one here, one, and the IP address, my instance IP address, escape, shift colon, W, exclamation mark. Okay, then I have to enable one. So fail to create syslink file already exists. Fine. So previously we have given already, right? So let me do Nginx test. It's getting failed. Mm, okay. So as Nginx is spelling, let's do with Apache. So let me do for Apache as well. So vi slash etc slash um, Apache 2, Apache 2 and sites available. I will label slash Rajni dot, let me copy this, or let me write down Rajni 1 dot triple O dot com, or we can also not to provide this one and we can directly do this thing also. So what I'll do, I've already written in the notepad, then let me do this one. So here I'm going to give 1 and then escape shift colon w exclamation mark, escape shift colon w exclamation mark. So we have to give sudo. So now 1 escape shift colon w exclamation mark. So can't open a file. Can't open a file. The press enter type to command. Escape. So it's available. It's to can't open file. QA. Let me open with the nano. Directory does not exist. Acha, the thing is, apt install Apache -y. We are not installed, but we are trying to. Now, let me go to the same and insert, give it as a 1 and escape shift colon WQ exclamation mark. Okay. And what's happening? Mhm. Available. The right spelling on the right. Available. Okay. Available. AVAILAVLS. Now, yep. Escape. Colon W. Let's do one more thing. We stop this in another way. So what I'll do, we'll go with let's new one dot move dot com dot COF. So in this way we can do now here. Let me make it the changes in the notepad. One X Y save and let me go and run one more command. Before that, let me check one more time. This one. So you can find this all commands in my GitHub actually. Just need one dot move.com. No need. Okay, let's do restart. Oh, it's also failing there. I think there was a problem with the port numbers and enable syslinks. Okay, so to skip this, I don't know. I think I have done some mistake in some way, a spell mistake or some already created lot of commands. Just a little bit confusion. Don't be worried about it. So try understanding here at so we are already at 12:10. So I would like to be cover up few things again. So that's how I'm just skipping this DNS part. So this is going to be done. You can do your practice, but instead of going this, you can go and my GitHub and find out. So here in my GitHub, you can find out the commands if you go to other repositories. Okay. So here in all the repositories, you can find multiple repositories. In each and the repository, you can able to see this configurations. Okay. So and one more thing, as I said, so let's take GitHub. Yeah, here. So I can able to register. So let me give my name and so I'm not having an account here. So it is going to tell I'm not having an account. So now it is integrating with my database. Now we can see. So I can give any name here and I can give email address here and I can give my mobile number here. Okay. So it should be a 10 only and the password register. The account is registered now. You can see. If I right side go and my account, it is going to give you a name and all. So this is now it's working. This e-commerce application is working. E-commerce application is working. See, and the balance You can just do orders and go to go location and select your location and search the products and add it to my wish list, or you can go to the address and same things. So if you can see inside the cart, so you are not having any carts here. See, automatically it is loaded. Okay. So this is how microservices and the Docker containerization will do in the industry. I'm sorry for this DNS. Regularly I do the same, but I don't know the same command where it is went. So, and I would like to cover one more thing, CMD and entry point. So many people are getting confused in between. So my GitHub is github.com/Rajnikanth Wadla. Okay. So you will get my account. This is my account. So you'll be having this commands and all in the important documents, doc importance. So you have multiple files over there. You can just check it out. Okay. So now, where am I? Yeah, covering the CMD and entry point. GitHub, GitHub. Yes, this is the GitHub. So let's open one Docker file. So in this Docker file, we have entry point, not a CMD. So what a CMD will do, what entry point will do. This is the important interview question. CMD will ignored by the Docker. Entry point will not ignored by the Docker. Okay. So let's do something. Where is my this one? Playground. Yeah. I have my playground here. Let me delete this Docker file as well. rm-f Docker file. Let me write one more Docker file. Docker file. So I'm writing this for CMD, okay? From Ubuntu colon 2.4 or 2.1, or let's take directly Ubuntu 1. And now I'm giving CMD. So I'll be providing one argument as echo and one more argument, comma, echo, hello, Rajnikanth. Close this. Okay. Now close this one, WQ expect mark. Now run this sudo docker build -t. I'm going to give a name CMD itself. Capital letters will not allowed for the image name. Small CMD and dot. Now Docker images. You can see I have CMD image, and let me run Docker run my image name. Whenever you give CMD is a default CLI argument or CLI component thing, which is going to execute while your container is running. Now what we are doing, we are trying to run a Ubuntu container, and I have given a CMD, which is CLI parameters, to give hello Rajni. Okay. So before that, I have given one parameter, which is echo. When I ran, it is giving me hello Rajnikant. Okay. So the same way, when I'm running with hello Rajnikant is there, right? Now I'm going to run Rajini. Okay. I'm giving an external pass. So it is going to fail because it is ignored here. Okay. CMD, whenever I'm passing one more command externally. So here it is ignoring. The daemon is getting ignored. So it is not considering me because I already given CMD. Okay. When you use CMD, whatever the goal, whatever the parameter you provide inside the Docker file will go into execute. Outside, while it is running, if you're given, so it is not going to. So Rajani is not an executable command. Let's give an executable command. See, now it is taking an executable command. So the system defined command, if you not provide, it's not going to take. That means it is ignoring. So to give you a clarity on it, I can give you one example. So you are in your home. Today is Sunday, and after this class, your mom told to go out to the market and bring some vegetables or chicken or mutton. You went outside and you went to vegetable shop. Your mom told to you in home that bring tomato and brinjal and onion. Okay. So let's say you went to a vegetable shop and you picked up tomato. So while you're picking the tomato and your uncle, your neighbor uncle came and he said, "Hey, why you're taking tomato? And you can also take capsicum also along with the tomato." So now you are ignored. Okay, you are ignoring your mom instruction. Your mom told tomato you have to take. You are ignoring that and you are listening to the uncle's instruction. You are going to take capsicum, not tomato. Okay, so this is Docker going to ignore on the scene. Let's do on the entry point the same. Okay, so if I go and edit stupid uncle's instruction. Okay, now let me do the change in place of CMD and I'm going to keep entry point. Okay, so now escape shift colon WQ expect now. Now I would like to build an image for entry point. So I'll call it image name as entry only. Docker images. Now I'm going to run my image, entry point image, entry. So when I hit enter, it is going to print hello Rajnikant. So here I can give one more like Rajini. Instead of hello Rajnikant, I'm giving Rajni here. So it is going to listen both. You can see now it is giving hello Rajnikant, Rajni. So that means here you're listening to your mom instruction along with your uncle instruction as well. So that is enter point. Exceptionally, you can give system defined commands as well and not defined commands as well. Entry point can listen. So Docker daemon will not ignore your entry point instructions or entry point commands. Okay. Now you can use CMD entry point same in the Docker file, but mostly in the industries right now, we use entry point only. If you can see here as well, I've used entry point only. So this is how I will provide the parameters. Okay. So this is param 1, param 2, and param 3. So Nginx has to be started daemon off. Okay. So like this, we provide some commands. And no need to worry about this, how to write all these instructions. Okay. These are all available in the Google. You can just go ask Bing also. You can ask Docker registry as well. So they are providing how to write a Docker file as well. So the only logic we need to apply at this environment variables level. Okay. And one more thing. So many people are having a difference confusion between copy and add. So what a copy will do, copy will copy the files from your folder to the Docker image into this app directory. Then what about the add? Add also will do the same thing. It is going to copy all the files to this app directory. But when it is copying, it is having a one more feature. Copy will only copy the files which are available, but add can copy the content which is not available in your server. If you provide the URL, like we have went to the static site, right? So we came here and we copied this one, right? So we can provide add, so that is going to copy. So it is going to do unzip. So this is the difference between copy and add. Copy will only do the copy, but add can download from the web and it can copy into the Docker image. And if you're providing zip format of the files, it can unzip and copy into the Docker image. So that is a feature add is having and copy is not having. Okay. So in interviews, these two are the important questions asked in many interviews. Okay. I hope I have covered maximum things. Still, lot of content is there. I need to be show you volumes, networks, and other network connectivity ways, and some mechanisms of the containers, at how we use in a real time. But need to take a more time for it. So as we are left with few minutes, and I would like to tell you, I'm going to start two batches. So one is from tomorrow, completely online from Feb 12. It's not coming. Let me go to from Feb 12 online, 8 p.m. IST. And from Feb 14, 7:30 a.m. online and offline at Kukatpalli KPHP. Okay. So tomorrow online I'm going to start, and Feb 14 at 7:30 a.m. I'm starting offline come online. Okay. So whoever wants to come to offline, just please reach out to the admin and then register yourself. Thank you all. I hope you can do practice. If you're not getting any comments, just go to my repositories in my GitHub and you can able to find. Or you can go to the same Docker Hub as well. You can have multiple microservices images available over there. You can do your practice. Any doubts? You can reach out to the Naresh IT, Naresh IT admin. If you can search here, Naresh IT. Okay, so contact. Call this number. Call this number. So they'll give you full details on. Okay. So my training is completely on the real time based. I think you already got the point and how I would be get into the topics. So I'll be teaching you basic theory and then I'll immediately get into the practicals. So the practicals can only make you the a real time employee. Okay. So my way of things are is completely into real time because I'll be developing every day new projects. So I'm going to teach the same things to you, how the industry is applying the methods, how the industry is applying the technology, what are the connections and mechanisms our industries are doing from the service, from product, from the projects. Okay. Yes, we'll be going to cover all Docker, Kubernetes, all Ansible, all the DevOps tools, including Jira management. I'm going to give you the task, the Jira. You have to do and come to me as a real-time employee. Okay, I'm going to give you few repositories. You have to execute and make that happen. That application should be up and running by using few tools. I'll give you the goals after our classes. You have to execute that. So before that, I'll be going to teach you all the things how you can make yourself to deploy one successful application. And even those repositories you can showcase in your resume as well for your interviews. Okay, we are going to build a real kind of applications. Okay, so we have took a Netflix clone. In the same way, I have many repositories. So I'll be teach you how to write your custom code, and I'll be teach you how to use ChatGPT as well. So these are all included in my course, where it makes you a perfect 3 years experience guy. If you're a fresher also and experience also. Okay, I can give you the word on it. So I can see some chats. Terraform on Kubernetes also, yes. Docker Kubernetes also, yes. Terraform, Ansible, Sonar, and other JFrog, and GitHub Actions, GitLab CI/CD. Not only Jenkins I'm going to cover because Jenkins is getting out of date. So my main focus is to teach you on GitHub Actions and GitLab along with Jenkins. Okay. If you go to throughout the YouTube, you'll find only Jenkins. But in the industries right now, we have a lot of advantages by using GitHub Actions and GitLab. So everyone is moving to that, and I'll teach you that as well, along with the Jenkins. And we'll be going to cover other as well, other build tools and Argo CD, okay, how to use the Argo CD and Helm charts. So like this, and Ansible, Terraform. Uh, so it is a DevOps batch. Yes, so it is a DevOps batch, and in this course, I'm going to include AWS as well. So without cloud knowledge, there's a no main, there's a nothing to learn the DevOps. So damn surely you have to have a cloud knowledge. So first we're going to cover up network, cloud, then DevOps. Now I'm going to use AWS Kubernetes, which is managed Kubernetes. So it's almost going to be 3 months, 2.5 months. Okay. So close to 75 to 90 days. Okay, then thank you everyone for your patience and making my workshop successful. Thank you. So we'll meet in our classes. Whoever wants to come, I can say don't miss out these practicals from my side. Thank you all. Have a great day.